Okay, then good morning and welcome to our today's webinar about FIWARE Data Spaces, a practical introduction into roles and components. My name is Stefan Wiedemann. I'm a technical lead and architect at the FIWARE Foundation, and I'm working on the topic of data spaces and the components that FIWARE uses for data spaces for now about 1.5 years. And I hope I can give you a brief introduction today. Let's start first with our agenda. I think the first point that we need to clarify is what is a data space? And we don't have to talk about components in a data space if we don't have an idea of what a data space itself is. As second point, we will take a look into the data space and how we set it up and its concrete participants, most notably the trust anchor, the data provider, the data consumer, and the marketplace. And as the last point of our agenda, in my opinion, the most interesting one, the live demo of our local data space. I promised in the invitation that everybody should be able to set up a local minimal data space after the presentation. So hopefully I'm able to do this today. And then you can repeat this on your own machine later. Okay. Then first, have a look. What is a data space? There are a number of definitions out there from various initiatives, mostly in Europe, but there are also some worldwide. I took 4 out that I think are quite relevant. The one from the Open Data Initiative is cited in various publications already. That's something that comes, as far as I know, from the European Commission. And it defines a data space as a decentralized infrastructure for trustworthy data sharing and exchange in data ecosystems based on commonly agreed principles. Gaia X, for example, defines it a little different. It sees a data space as a federated open infrastructure for sovereign data sharing based on common policies, rules, and standards. IDSA defines a data space as a secure and standardized digital infrastructure that enables trusted data exchange and database services among various stakeholders. And as the last example of a definition, I took the one from the DSBA, which states a data space can be defined as data ecosystem built around commonly agreed building blocks, enabling an effective and trusted sharing of data among participants for the creation of value. We already see that this is not that there is not really a single definition for a data space, but they essentially all describe more or less the same thing in different variations. So obviously, all of them want to share data to a certain degree or offer data services between different participants. They talk about decentralized or federated, so overall at least an infrastructure that not belongs only to one organization or participant, but is actually distributed through multiple participants of a data space. And all of them also want to have something like common policies and rules, standard, and a certain trust between all the participants that interact with the data. So to summarize, there is not really a single definition of a data space yet, at least not that I know of, but there is more or less a common view on a data space. The data space itself is usually formed by different participants, mostly organizations that interact together with their data. Those participants have to agree on common rules, standards, and policies that essentially regulate the data space. The data space itself is a technical solution to share data and services, so we don't talk about sending papers around here. And the technical solution is usually accompanied by legal solutions because not everything, all rules and policies that we define for a data space can also be technically enforced, but there is usually also a requirement to have a legal framework around our data space. Then let's have a look how we build this in FIWARE. So in a FIWARE data space, I already mentioned in the agenda, we essentially separate between 4 different participants. The participants itself will fulfill this as a role. So we have the data provider, which usually is the one that offers data or a data service to other participants. We have a data consumer that wants to access data, consume data, or use the data service offered. Then we have a marketplace that should enable the data providers to offer data and support the consumer and the provider to do their contract negotiations, to buy data, or just provide a catalog of the available data. And then we have a fourth row that is the trust anchor, which is mostly required to ensure trust between the participants. The trust anchor is not necessarily only one, so we are able to support multiple trust anchors depending on the requirements of the data space itself. One important thing to notice is that even though we separate between those roles, especially today in this webinar, basically to make it easier to understand, but every participant can also fulfill multiple roles at once. So it's not that a participant is limited to be a data provider. It can also be a data consumer at the same time. And it even could offer a marketplace, the marketplace functionality also at the same time, for example, just for its own data services. So we will continuously separate between these participants for, let's say, educational reasons, but there is no requirement to actually have a participant only fulfilling one role. I will now go to the trust anchor as the first participant in our data space, because it essentially stands in the center of our database space somewhat. The responsibilities of the trust anchor inside our data space is mostly to provide the capabilities for the participants to identify together. So a participant needs a way to know that somebody calling it is also a participant in the data space. When I'm a data provider and somebody comes to me, I want your data, then I want to know if this one actually is part of our data space or if I should reject it. And another thing that's important, at least for our setup of a data space, it should ensure independence from single participants. So the trust anchor itself will take care that let's say, an entity that can ensure that the whole trust does not simply rely on one participant of the data space, so that it can be so that they have to trust a single participant, but the trust anchor can ensure the common trust between the participants. The trust anchor is often seen as a part of something called the data space operator, which could also be seen as, let's say, role inside the data space, but it's nothing that we have clearly defined in our idea of a data space. The data space operator is generally seen as something that defines the criteria for the participation and also might provide capabilities for onboarding into our data space. And the trust anchor essentially is then what's provided by the operator itself to the other participants, because we somehow need a way to get the participants into our trust anchor. This can be done manually, but it could also be done through automated processes, depending on the needs of the data space itself. The setup of the trust anchor is also not a single option, I would say. The trust anchor could be, so we could have just one single trust anchor in our data space that defines the participants. This can be centralized, let's say, with a traditional SQL database or any other database under the trust anchor. But it could also, for example, be a decentralized one, like it's proposed by EPSI, where the participants are stored on a blockchain, and essentially every participant reads out the information itself. And we, as mentioned, we also support the usage of multiple trust anchors, so that every participant can essentially, or the data space can define what trust anchor should be used for what kind of interactions inside the data space. One important thing to say there is that the trust anchor has, because of this, has to participate in the authentication between the participants. Because of that, I would give a short overview of how the authentication in a FIWARE data space looks like. Authentication in our data spaces is based on decentralized identifiers and verifiable credentials. This is those are rather new concepts, which is why I would give a short introduction on what it actually is. So a decentralized identifier is a new type of identifier that enables a verifiable decentralized identity. What does that mean? In the end, the identifier can be resolved to a document which can express verification methods, cryptographic material, or services that prove the control of this identifier. Decentralized identifier are usually the abbreviation used for decentralized identifiers usually is DID, which is why I also used service to prove control of DID here. And yeah, the interesting thing here is that in the end you only need this decentralized identifier, and you can check that something was assigned by actually this identifier. I have two examples of decentralized identifiers here. They are always created as URI with the prefix DID. Then the second part of the URI is the scheme of the decentralized identifier. There are various around there. I've chosen key and web here because they are, let's say, easy to understand for the concept. And the scheme itself defines essentially how the last part of the identifier should be used to retrieve a public key or verification material from the decentralized identifier. In the key, that's quite easy because the third part of the decentralized identifier is essentially the public key that can be then used to verify any signature done by our participant. So once the participant signs something with its private key, everybody can verify that it actually comes from the holder, that the signature actually is done by the organization or participant behind this decentralized identifier. A little more, not necessarily complicated, but interesting is the DID web, because that defines that the third part of the identifier tells us where to get the DID document from. So it usually is, or it is a host address that should be then resolved by the receiver through HTTPS, and then it can get a DID document from the well-known path there. The DID document somewhat is similar to, let's say, JW key set that we usually know from the OpenID world. And this document then can be used to extract the key material and verify all signatures. The second part of our authentication then is the verifiable credentials. Verifiable credentials in the end are just signed JSON documents. The typical formats are either JSON linked data with proof inside the credential itself, but the more commonly used one is a JWT credential, which essentially is like our traditional JWTs, but just more or less defined how the format of the content looks like, and then how the key ID can be, essentially the contents of the credential are defined as a verifiable credential by a W3 standard. It can contain essentially any information about the trust, any information, and the trust inside the credential depends on the issuer of the credential itself. And in combination with the decentralized identifier, we have a secure way to do authentication inside our data space, because the credential itself is then signed with a digital, with the decentralized identifier's key. And we know that the credential comes from one of our participants as long as we have it registered at our trust anchor. So how does it look in practice? We have our participant A essentially issuing a credential, so a JSON document, to an actor. The actor could be, for example, an employee of the participant, or it could also be a service, like we know it from, let's say, service accounts in OpenID Connect. And the actor then, the credential itself contains claims about the actor, for example, the name, the email address, a role, or any other permission that we want to encode inside our credential. And this credential is signed with the decentralized identity of our participant A. Then the actor can use this credential at another participant of the data space to authenticate itself. The other participant then can use the signature on the credential together with the decentralized identifier that is contained in the issuer to verify that this credential actually comes from participant A. And as a second step, it checks just that this decentralized identity comes from, so it checks the decentralized identity at the trust anchor, that it comes from an actual participant of our data space. We just require a single API from our trust anchor. That's the APSI defined trusted issuers registry API. It's a relatively simple API where you just go with your decentralized ID and either get a 200 or 404 response, and then we know if it's a participant of our data space or not. Okay, let's come to the next participant, which is the data consumer. The data consumer usually wants to consume data from other participants or use the data service, as we already know. And the data consumer, as every other participant, has to be registered at the trust anchor. A data consumer, when it wants to consume data from our provider, needs to properly authenticate. This is why we only required the pure consumer to have the functionality to issue verifiable credentials to its actors and provide the right claims for users, services, and the purpose that they should be used. We don't have any more additional requirements to the data consumer itself. That's why the setup of a consumer is relatively easy. We need an issuer of verifiable credentials. In the FIWARE data space, we usually use Keycloak for that. The latest release of Keycloak from beginning of this week now has support for OpenID for verifiable credentials issuance, which is a specification from the OpenID Foundation that is quite similar to the OpenID Connect standards, but just extended to be used for verifiable credentials. This Keycloak then can issue credentials to services or actor that they can use on behalf of our data consumer. These credentials can include claims per actor, which would allow a fine-grained definition of permissions. So let's say our data consumer want to differentiate what, let's say, marketing employee and data scientists can do, then it can issue the role marketing to one actor and data scientist to the other. Obviously, the data provider needs to understand those roles, so they need to be somehow defined as part of the data space, or at least of the data provider, and should be made public as part of the data offering itself. As mentioned, we currently don't have any additional requirements for a pure consumer. And as also mentioned, we're not just restricted to issuing credentials to, let's say, humans. It could also be just carried out by a service, and then the service itself authenticates with the credentials. On the other side, we have our data provider. The data provider obviously provides data or services to other users of the data space. A data provider wants to do a little more. So, for example, wants to restrict access to participants only of this data space. It obviously could also offer the data to anyone else, but then this is not something we really have to care about in our data space. We just focus on the portion where the data offerings are restricted to our participants. The data provider also wants to define access policies and access levels to the data and also enforce them, because just defining them obviously is not enough if you don't enforce them. Let's say those only want to give access, read access for everyone in the data space, but the service itself can only be used to participants that actually purchased access to it. And it also wants a fine-grained control about the access. That means, for example, the role separation that I brought for the data consumer, or it only wants to make data available to certain regions of the world or at a certain time. So there are various requirements from data providers depending on their domain. and we need to somehow support this level of control for our data provider. How are we doing this in our FIWARE data space? So the data provider itself has a couple of more components than the consumer itself, and they can essentially be split up into 3 different categories. We have the services used for authentication down here, which is the one I colored yellow. We have the components for authorization here, which is green. And we also have our data plane that actually offers the data or the data services. I would like to start with the components for authentication. And the most central of them is the verifier. The verifier component is responsible for actually interacting with our user or service that wants to access the data and carry out the authentication. Therefore, it offers an OID for verifiable presentation compatible endpoint, which is the somewhat the equivalent to the OpenID for verifiable credentials issuance that I mentioned before, just now for exchanging the credentials between participants. The verifier receives a credential at its OID for VP endpoint and then has first to verify the signature of the credential. Then it will verify that the issuer actually is a participant inside this data space. That's where the trust anchor comes into play. So the verifier will ask at the trust anchor if the issuer is a participant. And as a next step, it will also verify that the credential only contains types and claims that we as the data provider itself allows for that issuer. That means that we have here the chance to actually carry out the fine-grained access control that we want to have. So only participants, let's say only participants that are actually bought access to our data service are allowed to assign the role user or use credentials of type data service access credential, so that we can control who is actually allowed to use our services. And after this whole process, after the credential is verified, we return a JWT token that contains the claims we already verified, so that the JWT token then can be used on all downstream services inside our data provider. And the downstream components don't have to verify the credential itself anymore. They only have to check the signature of the JWT token with our verifier itself, which is yeah, I would say very close to how we already know it from any traditional OpenID Connect flow, where we also receive JWT tokens on our services and just check at our JWK endpoint and then the signature of the credential itself. We have 2 additional services in our authentication flow here that are mostly supporting the verifier in its work. One is the so-called credentials config service, and this has essentially the single purpose to configure the trusted issuers registry and lists responsible for a service certain credential type. This is important because then we can differentiate which trusted issuers registry to be used for a credential and also the trusted issuers list. I think the trusted issuers registry is the more interesting part here, because that's where we support the usage of multiple trust anchors. If we have a data space, or if a data provider wants to participate in multiple data spaces, it can here define which is the participants list to actually look into. And then we have the trusted issuers list, which is most of the time local to our data provider. And that allows more details about the credential types and also the claims inside those types that we allow for an individual participant. Basically where we define that only participants that purchased access are allowed to give out that credential. The trusted issuers list is in our case also implemented with the EPSI trusted issuers registry, so that we can integrate it with various options for that are available. We use a relatively simple implementation from FIWARE here, that just stores this information inside a MySQL database. Then let's take a look at the components for authorization. The central entry point here is the policy enforcement point. So every request to our data plane should go through the policy enforcement point. Therefore, this is essentially the, I would say, the public-facing API for our services. As mentioned, it's the entry point for all requests. The policy enforcement point itself then has the responsibility to request decisions for every request at the policy decision point. So the policy enforcement point itself does not decide about the request, it just enforces it, which means either forwarding the request to the data plane or reject it. In our case, we're using API6 as the PEP, which is an API gateway from the Apache Foundation, an open source solution. Which also can provide additional functionality if you want, like access logging, rate limiting, etc. And it's also possible to use other API gateways for that. For example, Kong, or you could also use plain proxy like Envoy here. But the default for our data space is API6 because it essentially supports everything we need as open source. So we have it here. The second step is the policy decision point, which then has to actually decide about the request. It will evaluate the policies and additional information together with the request, and then either allows the enforcement point or denies the request itself. We are using the Open Policy Agent here as a policy decision point. Sorry, that's a mistake in the writing. So we use the Open Policy Agent as a policy decision point. Open Policy Agent is also an open source community, open source component from the Cloud Native Computing Foundation. I think it's most noticeably known from the from Kubernetes, where it's also responsible for carrying out the RBAC rules. So it's a fast and well-supported component that we can just rely on here instead of essentially implementing something ourselves. The one component that we have from FIWARE in this ourselves is the so-called ODRL PAP, because for our data space, the policies are defined in ODRL. ODRL is the Open Digital Rights Language, which is a language to describe digital rights and permission. Which we also use to define the access to our data inside the data space. The ODRL PAP essentially just offers an API to manage those policies, and it then translates those policies into Rego. Rego is the policy language understood by the Open Policy Agent, and the PAP then offers those policies to the Open Policy Agent through a well-defined endpoint. So that we can use it as the decision point for our requests. We allow the extension of ODRL here with individual profiles that then fit our that can be used to make them more compatible with the domain that the data provider is actually acting in. And as a last point, we have the data plane itself. In a FIWARE data space, this typically is an NGSI-ID compatible context broker, so which is why we have Scorpio here as a default in our data space. But it does not have to be necessarily an NGSI-ID context broker. It's best supported by the policies that we already have, or let's say the ODRL profile that we have already in our ODRL PAP. But as mentioned, you can extend the profile, and then you can use essentially every other service as a data plane. You could also even use multiple data planes, so you're not restricted to just one single data plane. You can have a Scorpio and essentially unlimited number of other data services. That mostly depends on your resources then. And we currently only support REST-based communication, which mostly comes from requirements. We can support other protocols. That's easily possible with the setup, but we just don't have it yet because we didn't have any requirements for that in our data spaces yet. And then we have the last component, the marketplace. The marketplace itself should provide a catalog of available assets and services. So essentially what we have in our data plane from our providers. It should support contract negotiation, so functionality to offer, sell, or buy access to data and services, and support the participants with the functionality to actually carry out that contract negotiation and selling process. To do so, we have an implementation of the TM Forum APIs. TM Forum API is a standardized set of standardized APIs from TM Forum, which is also I'm not sure how the abbreviation is, but it's also let's say specification body, mostly out of the telco environment, which provides APIs that are very much focused on products, offerings, resources, services, and they are already widely used and very mature, so we decided to use those. In our default data space, the product and offerings, etc., are stored inside the context broker because that enables us to connect with essentially every other NGSI LD component that we have in the FIWARE catalog. In addition to the TM Forum APIs, we have a component called contract management, which more or less only listens for the product orders in the TM Forum API. So when a participant buys access, a product order is created, and then the contract management is responsible for actually enabling the access at the data provider. It goes to the APIs of the data provider and then creates the necessary entries in the trusted issues list and potentially the policy administration point to allow the issuer, the participant, to access the data then. One benefit of using TM Forum API is that it integrates well with FIWARE components for marketplace, like the BAE marketplace, which is essentially a full application for marketplaces with front end, with some backend logic that can directly be used together with our FIWARE data space. Okay, now that I already told some stuff about all the participants in our data space, we can go to the demo, which we call the local minimal viable data space. So the idea is to have a data space running on your local machine where you can start to play around a little bit and understand the concepts used in our FIWARE data spaces. To set up this data space, it's relatively easy. You just have to check out the Data Space Connector repository and then run a single command, which is called maven clean deploy plocal. What happens then is it will set up a local K3s cluster on your machine. K3s is I would call it smaller version of Kubernetes that is intended to run, for example, on edge devices, and it's well suited to just run on a local laptop and provide you a proper Kubernetes API, so that the local minimal data space will look very much like it would look also in a, I would say, production-ready Kubernetes environment. I will now do this, show you this data space directly in a live demo. The only thing that I already did is I already run the maven clean deploy local command, because it takes about 5 to 10 minutes to set up the whole data space, which mostly depends on your current on your computer and your internet connection. It took about 6 minutes on my system here, and once we have that, we can just check. We can connect to the local Kubernetes cluster with providing an entry to our kube config. So that requires you to have a kube control already installed, but that's something I would take as a precondition. And this year, if you don't know kube control at all, I think that's something you should read before using the local data space, because it makes the interaction easier. And now we can have a look into our local cluster, what's running there. We can see essentially 3 namespaces: the consumer, the provider, and the trust anchor. The K3s is already configured to to support our local environment. So we have now ingress rules so that we can access the data space through normal HTTP addresses. We have 3 namespaces created, one for the provider, one for the trust anchor, and one for the consumer. And all components are already installed in there. The local data space uses the same Helm chart that we also provide for the data space connector to be installed in, I would say, real-world environments. The Maven command then renders out those Helm templates with some values that are tuned to work well on a local machine. For example, it uses did key for all of the organizations inside our data space, because they are, let's say, easy to generate and to resolve inside a local data space. I will go back to the overview of this data space. Our local data space has 2 participants, the data consumer and the data provider. The data consumer is called Fancy Marketplace, and the data provider is the M&P Operations Incorporation. The idea is essentially to further extend that later, but Fancy Marketplace will offer services from our data, from other participants inside the data space, but it also can be data consumer because it wants to run its marketplace services somewhere. M&P Operations offers its digital services. For example, you can buy managed Kubernetes there, or VM service, whatever. And to the data space, it first wants to offer all participants access to the energy reports of its machines. That's what Fancy Marketplace will access as a data consumer here. That's the general setup of our minimal data space as of now. And that's what's now running after the command inside our machine. All the participants are already pre-registered inside our data space. We can access the trusted participants list under this address, which is called, I can make it a little bigger. We call tier here, which is the abbreviation for the trusted issuers registry. When I now do this request, we can see we get back essentially a JSON which contains our 2 participants. This is the did key of 1, and this is the other. I actually don't know which is the provider and consumer right now, because from a data space perspective, from trust anchor perspective, we only know that there are participants. We don't know their role, and we also should not necessarily be interested in, because they can also have multiple roles. That's why the trusted issuers registry just knows this is a participant and this is a participant. If we now go further, we can take a look into our data consumer. As already mentioned, the only real thing that our consumer should do is issue verifiable credentials. Therefore, we have a key cloak running for our data consumer, which you can see here, key cloak consumer on our local host. I already opened it or loaded it, so I can do a reload. And then we can log in with the pre-configured test user to the account console. So this is actually the latest version of KeyCloak 25, which has in the account console an entry called verifiable credentials, where you can now get an offer for a verifiable credential. Those that know the process of usually getting verifiable credentials might already have an idea what happens here. So this is now a QR code which you can scan with your wallet and get a credential. Actually, this is something that we currently not support in a local data space, because that would require the wallet to access the endpoints of our KeyCloak inside the environment, and that we don't have a wallet that is capable of that at the moment. But we have a description how you can get a credential anyways, because there is also a process that, for example, would be carried out by a service, let's say by a service running inside your environment, That would also not scan a QR. It would go directly through the APIs, which is what we will do now here. All the commands are inside the documentation, so you can play around with that easily and have a look at all the things that I also do here now. To get a credential, we first have to get, obviously, an access token to our key cloak, else we won't be able to access the endpoints that we want. So now I will try to get an access token. This is the typical command. In this case, we're using the admin CLI as the client, and we're using the username and password of our test user. We have an access token here now, and if you just use the commands, it will store them in an environment variable so that you more or less mimic a wallet on your own machine. As a next step, we could get the OpenID credentials issuer information from our key cloak. We don't necessarily know that because in our data space we already are aware of that, but it contains information about the issuer endpoint, about the credential endpoint to be used, the authorization service that you can use to get tokens for accessing it, and also about the credential configurations that are supported by this installation. We have two types of credentials supported here, the verifiable credential and the user credential. And both support the format JWTBC, which is what I explained at the beginning in the authentication. So you can get a credential that is encoded as a JWT token, essentially. Now we want to get an offer for such a credential. So the flow in OID for BCI usually goes through retrieving an offer and then taking this offer and getting the actual credential for it. First, we have to extract the offer URI from our key cloak. It has an API for that. This is what is usually also encoded as part of the QR code and then done by the wallet. So we will now retrieve the offer URI. It holds a nonce so that we can only use it once. And we need to do this a little quick because for security reasons, all those keys are just short-lived. As a next step, we will use this offer URI to actually retrieve the offer. The offer will contain a so-called pre-authorized code, which is a code that is bound to the currently authenticated session in our key cloak, and can then be used by whomever it has to get an access code, and that is also bound to this session, so that the wallet that is not necessarily running on the same machine as our user did authenticate itself with can actually retrieve the credential. This is also part of the OpenID Connect for OpenID for verifiable credentials issuance flow. So now we will get our pre-authorized code. This is the pre-authorized code, and this pre-authorized code then can be used to get the actually access token, which we can use to get our credential later then, or in the next step. So you can see here the grant type that we use is pre-authorized code. That is a pretty newly invented grant type, and this one can be used with our pre-authorized code to get an access token for our credentials endpoint or for our key cloak. And this is now the access token that, as last step, we can use to get our verifiable credential for. So let's go to the verifiable credential endpoint and get our credential. Again, as you can see, just another JWT token. But we can go to JWT.io and have a look into it and see that this is actually a verifiable credential. I'm not sure if it's big enough. So, first thing you can see that the key ID in our header is the DID of our issuer, essentially the DID of our consumer. And in the payload, then we have information. We have some standard claims, and we have the information of the verifiable credential, the type user credential, and information about the issuer that was configured in Keycloak. So the name and the rows that we should assign to it, and an email. Now we have a verifiable credential for our consumer. Now let's go to the data provider because it actually wants to provide some information to our users or to the participants. To do so, first it needs to create a policy that actually restricts or allows the access to the that allows access to the data, to its data, to the participants of our data space. As mentioned, we are using ODRL for that. So we have an example of an ODRL policy here. And that's the policy that we now will create at our provider. We can see the typical elements of an ODRL policy. So we define a permission, which comes from the assigner, our MLP operations corporation. Then we define the target. The target is essentially the data asset that the permission belongs to. In our case, we define an asset collection that is focused on all and that uses the NGS ILD profile and entity type, and essentially defines the permission belongs to every data and asset with the entity type energy report. So we say every request to NGS ILD with the entity type energy report should be part of this permission. We define an assignee. In our case, we say everyone. This is currently part of our ODRL profile. It should be taken to a dedicated profile because it's not part of the normal ODRL, but that's something that we will do in hopefully next week. And we say we allow the action ODRL read, which in our case maps to essentially HTTP GET. So once we have this policy defined, every authenticated participant should be able to get such energy reports. So first, let's create the policy. What we can see is we get as a response the policy in the Rego format, as it will be carried out by our open policy agent, or understood by our open policy agent. I would not go into the details of that because we don't have time left, but I want to just finish that. I hope that's okay. Then as a next step, we just have to create such an entity. Our local data space opens some APIs that are usually closed so that we are able to instrument it for testing. One of them is the direct access to our context broker. In a normal data space, this would not be publicly available, but we open it here for the local data space so that we can play around with it. I will just quickly recreate our demo entity. So this is now available inside our data provider. And now we want to see how a user can use its credential now to get this data. When we now go through the public endpoint of the data service, which goes through our policy enforcement point, we first will see that we won't be allowed to access it. We get a 401, which is somewhat expected because we didn't include any authentication information. And then we go, we do the normal thing. We just ask how to authenticate, which means we go to the well-known OpenID configuration endpoint. And in this case, we retrieve the token endpoint. I will show you here how the response looks like. So somewhat we have the token endpoint here. And one thing that's important for our endpoint, which is produced by our verifier, is that we support the grant type VP token. VP token means verifiable presentation token, and that's a way to encode credentials to present them to another participant. And that's what we will now use here. We will create a VP token containing our credential, present that to the token endpoint, which is our verifier, and then use the resulting JWT token to access the data. We will now create a local identity for our user. So essentially, this is something that a wallet usually will do. We have to sign the VP token with the identity of the one that's holding it. We're using a small tool here that just generates key material and key. This is now the key that we will use for our verifiable presentation. We export it to an environment variable for essentially the ease of use here. So we now have the key here for our holder. And then we will create the verifiable presentation. The verifiable presentation is also a linked data object, very much look like the verifiable credential, but it just contains a list of verifiable credentials and the holder of the credentials. We still have our credential as an environment variable stored. So I will just create that. We now have our credential here. You can see the verifiable presentation with the credential inside. And now we have to build a verifiable a VP token of it. The VP token is essentially a JWT token that is then also encoded as a base64 token. So we first have to create the JWT header. We do it here, base64 encoded as usual. Then we take our payload, which contains the verifiable presentation, the issuer, and the subject. That is defined by the VP token. And then we take both of it and create a signature with the key material that we created in the step before. Now we have the signature, the payload, and the header. All we have to do now is combine them to our JWT token in the normal way. So header, payload, signature. This is now our JWT VP token. And to use it in the VP token flow, we also have to do a base64 encoding for it. It needs to be unpadded, but that's more or less a detail of the protocol. This is now our VP token that we can use at our token endpoint, which is our verifier, to get a JWT token for. You can see here, we say grant type VP token. We go to the token endpoint, which we exported before, and we will include the VP token. That's not what should happen. What did I do? I did something wrong with at some point. Okay. No, I missed out a step somewhere. I think we don't have much time left. I'm not sure if we should go now. There it is. Okay, there's our access token. Then let's do it manually. Now we have an access token. And with this access token, we should be able to access our service. I think I used a different name for it, so let's do this and go through to our service again and get back our energy report. What we now had is when we did this exchange here, our verifier verified the credential inside so that it is from the issuer, that is one participant of our data space, and also verified that it only contained allowed credentials. We didn't do any restrictions here, so we did essentially allow everything. Then we got back our JWT token. We're going through the data service, basically the PEP. And the PEP first verified that this token comes from our verifier and evaluated its contents together with the policy that we created for, which means every authenticated user can get entities of the type energy report. That's essentially the basic interaction inside our data spaces. Yeah, you should try it out locally and play around with it to get a feeling for the data space itself. That's the essentially finish of my demo. The slides will be uploaded to my GitHub account under presentation folder, I hope before end of today. And then we're at the end of today's webinar. We still have a couple of time left for questions. Yeah, thank you for listening, and I hope I can give you some answers, or if not, yeah.